Hello everyone, welcome to AnalytixCloud. This is your host Gaurav, and today we are just coming up with a new playlist on SQL where we are digging into the very first topic of how do SQL indexes really work. So this is a very important question that might be asked in a data engineering interview, where either you are a fresher, or if you are a mid-level experience, or you are having a senior level experience. You must know how exactly indexes really works in the background. Okay, so in a data engineering interview, you might get asked what exactly is indexes, what are the type of indexes, but if you will also able to convince them that how do SQL indexes really works in the backend, so that will be an added advantage to you. And that's where we have uh, came up with the very important topic on indexes. Okay, so let us just start our journey on this SQL indexes by looking into types of indexes, how exactly creating the indexes helps SQL query optimization, how what is the performance difference do we see. Okay, so before we start, for all those people who have joined us for the first time, please follow us, please subscribe us so that we can bring more videos to you. So let us just start our topic with taking some example. Okay, so let us take some table, let's say which have columns, like let's say this table name is supplier tables. Okay, so this supplier table, let's say we have columns like supplier ID, which is the primary key of this table. Similarly, let's say we have supplier name, which is the name of the supplier. And similarly, we have, let's say, email, to which email of the supplier basically, and department to which the supplier belongs. Okay, so let's say we have these four columns that we want to have in a supplier table. Okay, so out of which this supplier ID is a primary key column. Okay, so as soon as you create a primary key means that it will have no duplicates. Correct, it will be not null. Correct, also by default there will be clustered index that will be created on this column. So this cluster index will be created on supplier ID column, which will store the data of the supplier ID physically in sorted manner. Okay, in sorted fashion. So till now what we have understood is we have created a table where we have supplier ID column, supplier name column, email column, department column, and we are keeping supplier ID as a primary key column. So as soon as we create or declare this column as a primary key, and by default a cluster index will be created on this column where it will store this data of the supplier ID in a sorted fashion. Okay, so let's say if we go into more granular detail, okay, let's say how exactly this data is stored. Okay, so let's say if we have one box. Okay, let's say we have having this as index rows. Okay, similarly, let me draw a few more. Let's say we have index rows. Let's say we have again index rows. Okay, so we have one more. Now below index rows, let's say we have data rows. data rows. Similarly, we have one more data rows here. Okay, let's say we'll have one more here. Okay, create one more. Okay, now for this last index rows which we are having, let us just create two additional data rows. One last. Okay, so basically whenever you are creating any table, and on that table if you are saying a primary key which is supplier ID, right? So that supplier ID will be stored, uh, sorted by the ID column, and it will be stored as a series of data, basically data pages, which will be in tree like structure. Okay, so basically once you create those clustered index, that will be created automatically. Once you define the primary key, the data will be stored in terms of series of data pages, forming binary tree, which we can see here, right? So if you see this index rows will be connected to this index rows, let's say. Okay, similarly it will be connected to this, similarly it will be connected to this. Okay, similarly these two index rows will be connected to each other, similarly these two will be connected to each other, and this index rows basically will be connected to the leaf node, which is data rows. Okay, similarly this index rows will be connected to these data rows, same for this index rows as well. Okay, so now you can see the index rows that we have is present only in the first level and in the last level, right? Sorry, in the second level. So if you'll see here, if I just change the marker, so this level is called as root node, right? This level is called as intermediate level. Okay, and this level is called as data pages or leaf nodes. So basically, whenever you are creating a primary key, all of the data will be stored in these data pages that we can see. Okay, now if I talk about a case where we are talking about the supply table. Now let's say supply table is having approximately 3000 records. Okay, so now let's say the supply data which we have is having 3k records. Okay, so now let's say first record up to 500 records get saved here. Okay, now here 501 to 1000, similarly 101 to 1500, similarly 1501 to 2000, similarly 2001 to 2500, and 2501 up to 3000, right? So you could see that the data that we were having in the supply table is divided and stored into different data pages. Okay, now let's say if I'm talking about this index rows that we have, okay, then we can say this side of this index row, which is the left side, is having supplier ID from 1 up to 1000, correct? Because you can see here it is up to 1000. Similarly, this side of if you'll come down here, this side of the indexes contains 1001 up to 2000, correct? Similarly, in this case it is 2001 up to 3000. Okay, so now if you could see, uh, with the help of these records that we have segregated, and with the help of these indexes at the very first node, which is the root node, we are clear that if we want to go have any supplier data which is between 1 to 1000, either I can go here. If it is between 1001 to 2000, I can go here. Otherwise I can go this side, correct? This is the first basically filtering that we did. All right, now let's say if I'm talking about a query, let's say I am writing select star from table, which is supplier table, where supplier ID is equals to, let's say, 2601. So what it will do, first it will come here, it will see that okay, from the index rows we need to come here. Okay, we as soon as we come here, okay, now down below these are the 2001 and 2500 records. So if you will create the indexes, like let's say the numbering, so probably here, let's say this is having 2001, sorry, 2500, 2501 to 3000. In this we are having 2001 to 2500, right? So first it will come here, we are looking for 2601, so it will check that 2601 lies here, then it will come here. So the first step is up to this point, second step is up to this point, and third step is where the records will be getting fetched, correct? So only in these three steps we were able to fetch the data that is there for ID 2601. Okay, now let us just do this practically. So let us first create the supplier table. Okay, so we can write create table, we can have supplier. Okay, then we can give column name as supplier ID, we can give int primary key, and let us make this as identity column so that it will keep on giving that an incremental values. Okay, then we can have supplier name, we can give it as n varchar, let's say 20. Then we can have email, we can have n varchar as 20. Then we can give it as department and varchar 10. Okay, so let us just create this. So it is saying that we already have this object supplier, so let me just drop it first so that I could just show you while creating again. So let's say create table supplier. Okay, so now we have created this table supplier. So if you just query it, we can see the structure, but there won't be any data as of now, right? So now let us do one thing, let us try to insert values to the supplier, some random values, and try to make this supply table something having approximately 1 lakh records, something like that. So in order to do so, let us just declare some counter. Let's say declare we are declaring a counter where we, let's say if it is an integer data type and we will be starting it 1. Let us put some while condition where we will be running our loop for this counter up to, let us keep for 1 lakh records. Okay, now let us just begin this. So we can declare at the rate, let's say we have, so anyways a supplier id which we are not supposed to give because it anyways it will be by default loaded. So let us just continue with the supplier name where we have nvarchar 20. Okay, and let us just give it as shell. Then let's say I'll just remove any extra spaces that this counter might generate. Okay, let's say at the rate counter. Okay, so this is first part. Similarly we'll have to do for email and department. So if I'll just change this to email, let us just have shell, let us have some counter, and let us add AnalytixCloud email here, analyticscloud.com. Okay, now let us take department, where let us just keep it as while department, and I believe let us just leave it as it is. Now once we have defined the variable, let us insert this into the table. So insert into supplier values, right, and then we can pass on this variable that we have just now created. So we have supplier name, we have supplier email, and then we have department. Okay, now let us just increment this counter plus 1. Okay, I think we are done. So let us just run this. So as you can see, it is executing. Okay, it is currently running. Once it finishes, then we'll try to view the data. So let's say it is already finished. So let's start from supplier table. So if you could see, now we have 1 lakh record that we have created, right? So we have supplier ID, we have basically that will be an identity as we have created. If you could see, each records in this table is given an identity values, basically an incremental values, and also this supplier ID is the primary key column that has got created. Now we have supplier name. So if you could see, we have used the counter. So there is the number that is being appended for each of this shell that we have given here. Similarly, for this email, we have given shell, and then there is the number that will be the counter that we have given, and then at the rate analyticscloud.com. Similarly, for the department, we have oil, and then we have this counter that we are passing. Okay, so now uh, let's do one thing. Now we are trying to do select star from supplier, right? So we can see we are getting these results. So if I'll go to whiteboard, so if you'll see where we have left, let's say we are trying to do a select star from the table where supplier id is equals to 2601. Correct, that means this supplier id in our case currently is a primary key column. That means by default this primary key column will have a clustered index on it, right? And because of this clustered index on it, it won't need to look for all the data that we have. Either we have it in this data rows, the first one, or the second data rows, or anyone. We can just directly go to the desired data, basically rows, based on the indexes that is there. Correct. So let's say if I'll do select star from supplier where supplier id is equals to 2601. Okay, now let us also include actual plan here. Okay, now let me just run this. Okay, so if you could see here, we have got this one record that is there for the supplier id, right? Supplier id is 2601, shell supplier name is 2601, and we have the same department. Now if I'll go to the execution plan, okay, now if you'll see, before we started studying this execution plan, I must say that the way to study this execution plan is from right to left and from top to bottom. Okay, so right to left, so we'll just first come to this. Okay, so here if you could see, it is clustered index seek that has happened. right? If in the top, if you could see, it is a clustered index seek that has happened, right? And if you come to the actual number of rows read, so here, even though we have 1 lakh records present in the table, still the actual number of rows that is read is 1. So this represent how many data does this SQL needs to read in order to generate an output. So here SQL only took 1 record to read, and that 1 record was generated as an output, which is actual number of rows for all execution, which is 1, which is the one output that we have got. Okay, so this is how you read your execution plan. Now also there are two types of basically scan that happens. Like let's say here, if you could see, there is index seek that has happened. Once we will run any query on the table on that column where there is no index, we will see the regarding what other basically scan looks like, okay, apart from this index seek. So now let's come to this select statement. Okay, here if you will see, the estimated subtree cost is nothing but 0.0032831. Okay, so if I just note it down, 0.0032831. Okay, so this was the time that was taken. Okay, now let's do one thing. And now let's say if I'll do select star from supplier, where supplier name equals to shell 101. Okay, so now what we are doing is we are trying to read we are trying to fetch the output of this query wherever the supplier name is shell 101. And you must know that we have not created any kind of indexes on this supplier name column, right? So let us just run this. Okay, this is showing us this data only is not available, somewhere it might be missing. So let's say we are passing supplier name. Let me just run this. So if I'll tell supplier 101, okay, there is no space in between, so I'll just remove the space. Okay, okay, so if you could see, we have got this record, which is nothing but the supplier ID is 101, for which we are looking. This is the supplier name and the email and the department. Now let us go to the execution plan of this. Okay, so now earlier, if you remember, we were having this as clustered index seek, right? But now we have got this as clustered index scan. Okay, so what's the difference is, let's say here, if you'll see the actual number, sorry, I'll just go back. Yeah, so here if you'll see, the actual number of rows that is read is 1 lakh record. That means in order to read that one data where name is shell 101, it had to read the entire 1 lakh records, right? And actual number of rows for all executions, which you could see, is 1, right? So that means it generates one output, that is one record. In order to generate that one record, it had to read all those 1 lakh records. So this is what is the difference between index seek and index scan. Okay, so index scan is the basically heavy operation, since it had to read the entire data, and that's where the execution time of the index scan will be more with compared to the seek, right? How we can see it here as well. Let's say here, if I'll go, you could see the estimated subtree cost is 1.13699. So it is 1.13699. So if you could see here, the difference is just huge, right? Earlier with the cluster index, this was the time that was taken. With the non-clustered index, not non-clustered index, for those columns where there is no indexes, this is the time that is taken. Correct. So in those cases where you might have basically, let's say, uh, such columns which might be used frequently to do some query, or which might be used in order to do some kind of join. So for those table, what is recommended, that you should go for non-clustered index. Okay, so basically if you will create a non-clustered index on those columns, your performance will be far better than what you are currently getting here, which is nothing but index scan. Okay, so now let's say just try to understand how this non-cluster index works. Okay, so this is what we just saw with respect to the cluster index. Now let me show you the non-cluster index. So let's say in non-cluster index, this is how your tree will look like. So let's say, one second. So this will have key values. Okay, so here if you'll see, we were having index rows, right? So this first two levels was having index rows, but here in non-clustered index, let me go back and let me write it for you. It is, let's say, non-clustered index. We are having key values pairs. Okay, similarly, let's say I'll just scroll it a bit down. Okay, now we will be having key values here. Let's say we have one more key value. Okay, we have one more key values. Okay, all of them are key values. Key values. Similarly, we have key values. Similarly, we have it here. Okay, now below this key values, we will be having row location. Okay, so let's say we have one here, we have one here. Similarly, let's say we have one here. Okay, let me just write it. Row location. Okay, now if I will connect all of these, basically these key values will be connected to, let's say, this key value. Similarly, this key value will be connected to this. Similarly, this key values will be connected to this. This key values will be connected to this row location. Similarly, this will be connected to this. Okay, now let's say this one. Now let's say this is connected to this one. Okay, now what exactly will this row location that we are seeing here will contain, right? So it will contain, let's say we are creating non-clustered index. So we are having supplier ID, we are having name, we are having email, we are having department. Correct. Now we saw that when we are able to find out, when we are able to figure which, let's say, which are the record that belong to particular supplier name, there was no indexes, and then that's where we thought of creating non-clustered index on this column. So non-clustered index could be created on multiple columns. Okay, so here in our case we are creating non-clustered index on this name column. Okay, so what this row location will contain, we will have supplier name. Okay, and then along with the supplier name, it will have clustered index keys. Okay, so in our case, clustered index keys is supplier ID, and the other value which we have is supplier name, right? Similarly, if I'll go to the top node, if I'm talking about the supplier name on which we have created non-clustered index, so that supplier name will be sorted in alphabetical order. Okay, so all of these key values will be having, which will be pointing to nothing but this row location basically. Okay, now how exactly it will look like? So let's say it will look like this, where you have one table, let's say. Okay, now you have, let's say, supplier name, since you are creating non-clustered index on supplier name, and let's say you will be having supplier ID, which is the clustered index for it. Now this supplier name will be sorted based on alphabetical order because you have created non-clustered index on it. So let's say first we'll have, if I'm talking about Indian oil, then first it will have Indian oil, then it will have Shell. Okay, even though it supplier ID belongs to 2, its supplier ID belongs to 1. Okay, so similarly in our case, where we have Shell 101 102, so it will be like Shell 101 Shell 102. Okay, so it will be stored incrementally. Okay, so this is how basically your data will look like. Now how exactly it will fetch? So what will happen, let's say now you are writing a query where you are saying select star from table, which is supplier, where name equals to Shell 101. Okay, so now what it will do is, with the help of this graph that we have, it will be able to figure it out. Okay, where is this shell located? Once it gets to know where is this shell located on that particular record, it will be able to figure it out what is the supplier ID of this record. So it just figured it out that we have the supplier ID as 1 for supplier name equals to Shell. Okay, now this supplier ID is equals to 1 is nothing but clustered key that is that created, that is basically we have created. Now on this information where supplier ID is equals to 1, it will come here. Okay, now from this particular graph, it will look for that supplier ID which is equal to 1, which is already stored here, right? So it will come here, it will come to this particular thing 1, it will come, which will be the first step in this case. Then again it will come here as a second case, and here the third step where it will be able to fetch that record from this data rows. Okay, so just to reiterate, now once you created a non-clustered index, your data will be stored something like key values pair, and then it will be at last it will be row location, where you will be having a combination of your a column name on which you have created non-clustered, plus you will be having a clustered key. So once you will be able to figure it out where exactly your supplier name record exists, From there, you will be able to figure it out what is the clustered key. Once you get the clustered key from there, you can follow the same step to reach out to here and look for that particular clustered key, and you can get the value for that record. Okay, now let us just do this in practical, where we were trying to run for the supplier name shell 101, and we just saw that it is taking index scan, where it is reading all those 1 lakh records in the actual number of rows read, if you could see, and it is taking 1.13699 execution time. Okay, so what we can do is we can just create a non-clustered index only on the supply name column as of now. So we can just write create non-clustered index. Okay, let's say I'll just name it as ix underscore supplier underscore name on, we are creating on supplier table on column supplier name. Okay, let me just run this. Okay, so you can see the non-clustered index is created. Now let us just try to run the same query, which earlier took 1.13699 time. Alright, if I just rerun it, I go to the execution plan. Now, as I mentioned, we are supposed to read this execution plan from right to left, top to bottom. So we'll start from here, where if you could see, it is now index seek instead of index scan, right? And you can also see it as a non-clustered index. So actual number of rows that is read now is 1, and actual number of rows for all executions is also 1, right? So it went to the non-clustered index. It just figured it out, one record that belongs to supplier name shell 101. Now, you could see here, it has done a lookup on the clustered, right? Because as I mentioned earlier, where first it will go to the non-clustered graph and then it will go to the clustered graph by taking those clustered key as an input, right? So if you go here, first it went to the non-clustered graph, it just figured it out what is the cluster ID, which is the supplier ID in this case. Then it went to this clustered and did a lookup and tried to find out that record. So once it done a lookup, it did a join. Basically, it did an inner join on that particular supplier ID in order to fetch all the records from that table. Okay, so that supplier ID is joined with the supplier table in order to fetch all the records, and you can see still the actual number of rows for execution, that is the output, is came as 1. And in the select, if you could see, the time that it took is 0.0065704, which is way lesser than this. So 0.006 something like that, right? 0.0065704. So you could see here what how drastically this performance gets changed. This query execution time gets changed. Currently, we were dealing with small number of records. Hence we are not hence we are not noticing this time difference much. But this time difference will really be huge if you are dealing with large amount of data. Okay, so I believe that's it for the first video, where we discussed on this clustered index and non-clustered index, how exactly these works in backend. Okay, and next videos we will be coming more on the SQL optimization techniques, where we will be going into a much more deep dive. Okay, that will help you to understand how exactly you can optimize your SQL query. Okay, so that's it for today. Thank you so much for your time and for watching our videos. Do follow us and do subscribe if you have not subscribed us yet, as it will really help us to bring more videos to you. Also, if you have any doubts, or if you want us to make any video on any topics that you want, please feel free to comment on the section below. Thank you.